Good morning, ladies and gentlemen. My name is El-Hamzawi, and I'm joined here by my colleague and lifelong friend, Mr. Omar El-Hamzawi. It's good to see you again, pal.
It certainly is great to see you too, pal, and I hope that we can help our viewers today understand how DNA is used in today's world.
Judging by the title of this video, most of you already know what we're talking about today. We're discussing DNA and how to examine it, the different process of collecting it, and the advantages of each one, as well as our collective opinion on which one we'd prefer to use in our lab. I'll get right to it and discuss the process of RFLP. For our less experienced viewers, this is the restriction fragment length polymorphism. So, RFLP is as follows. Restriction enzymes recognize very specific sequences of nucleotides in the DNA. Then, DNA from different people rarely have the exact same area of restriction sites and distance between said sites. As a result, the population of polymorphic, or having many forms, for these restriction fragment patterns, these differences then are called restriction fragment length polymorphisms, or RFLPs, and are caused by mutations for the most part. By cutting DNA samples with a specific restriction enzyme, DNA fragments of different length are obtained. These fragments are later separated by gel electrophoresis. This results in a pattern of bands that is completely unique for the DNA examined. As you may already know, these DNA fingerprints are used in forensic science during criminal investigations. RFLPs are also used as markers to identify particular groups of people at risk for certain genetic disorders. And as interesting as the process might be, I personally do not think we should be using this method for solving cases today, as it requires a large sampling of DNA, almost the size of a nickel, and it can take as long as a month to complete. It also requires rigorous examination of the sections of the DNA to locate variations, which leaves a lot of room for human error. However, in cases that are not as urgent, this may seem like a good idea since it's definitely cheaper than our other methods.
Has science gone too far?
Well, thanks, Mr. El-Hamzawi, for that great explanation on RFLP, and we're going to be moving on to CODIS. But first, we should stop by and take a look at STR, or short tandem repeats, and polymerase chain reaction, which is PCR. So basically, short tandem repeat is a molecular biology method used to compare specific loci on DNA from 2 or more samples. An STR repeat is a microsatellite consisting of a unit of 2 to 13 nucleotides, which is repeated hundreds of times in a row of a single DNA strand. STR analysis measures the exact number of repeating units. And so basically, this method is different from restriction fragment length polymorphism analysis, or RFLP, since STR analysis doesn't cut the DNA with restriction enzymes like RFLP does. Instead, STR uses probes that are attached to desired regions in the DNA, and PCR reactions are employed to discover the lengths of each short tandem repeat. And once again, as Mr. El-Hamzawi said earlier, I think STR is a lot more time efficient than RFLP because, first of all, it doesn't require as much as DNA as RFLP requires. Secondly, it's the same task in a much faster time, and so it saves time and it saves energy and hassle for forensic scientists who would rather have to wait a longer time and get better quality DNA. When it comes to PCR, you can really easily relate it to STR because in the end, PCR, or polymerase chain reaction, pretty much enables researchers to produce millions of copies of a specific DNA sequence in just 1 or 2 hours, whereas RFLP would take months. So basically, this automated process bypasses the need to use bacteria for amplifying DNA, which means that scientists don't have to go through the hassle of finding DNA and separating it when they can just use the polymerase chain reaction, because it simply just keeps doubling and doubling and doubling, and it makes copies of DNA. And now, ladies and gentlemen, hold on to your seats as we prepare for the one and only When it comes to CODIS, It was created by the FBI as a software pilot project in the 1990s, and basically its purpose is to serve the community or government as a database containing all collected DNA profiles, like a phone book with numbers. It's used to speed up the process of searching and or finding matches to DNA samples, as it contains all DNA profiles taken to date. The current CODIS software is basically designed for the storage and searching of short tandem repeat profiles or STR profiles, and I think the success of CODIS should be measured according to the amount of investigations, as there is no kind of basis to measure its success. So far, as of October 2014, which is just 2 months ago, CODIS has produced over 263,000 matches, assisting over 252,000 investigations, which I think personally is a pretty amazing achievement, as they have certainly aided the community, the worldwide community, and the American community alone. For all our viewers here, we have an interesting story that we'd like to share. It's a pretty heartbreaking story of Michael Phelps, a man exonerated after 25 years in jail. Please tell us more.
Indeed, this is a very touching story. In 1990, Michael Phillips was convicted of raping a 16-year-old girl at a motel in Dallas, Texas, where both of them lived. Phillips pleaded guilty because his attorney advised him that as a black man who was accused of raping a white teenager, a jury trial would not be in his favor. He was sentenced for 12 years and upon his release spent an additional 6 months in jail after failing to register as a sex offender. Nearly 25 years after his conviction, Phillips' name is being cleared due to DNA evidence. The surprising twist, however, was that he was unaware of the DNA testing at all. This was the first case where the defendant had not actually asked for exoneration. The woman who was raped said she partially pulled up the ski mask of her attacker and said she recognized Phillips. She also picked his photo from a lineup, which ultimately led to his conviction. But after the new investigation using DNA evidence, specifically short tandem repeats, it was determined that the other man was the rapist. Phillips finally went home a free man without even attempting to seek justice on a system that had failed him. He was also compensated $80,000 for every year he spent in prison.